Sometimes identical object questions are hard to figure out. That they are such things. So here I'm going to draw the streets out here. 8 blocks, 4 blocks east, 4 blocks south. So I'm going to go and draw a grid. Divide it into 4 this way, divide it into 4 this way. And Graham is walking from his home to the library. He walks east and then south. Would you agree that his home is up here and the library is down there? Okay? And Graham is smart. Right? Graham doesn't go to the library and go like this. Oh, where's the library? I wish I could get to the library. Hey, there's my house. Oh, where's the library? No, Graham is not. Oh, I found it. Graham is a smart guy. That would not be a route. He knows that he has to go 4 blocks to the east and 4 blocks to the south. He doesn't backtrack. So, for example, he might just go straight this way, straight that way, and get there. Or this would be another possibility. No, we're going to be night. Oh, you're saying it.
Oh.
There we go. Trying to stay on the roads, but not like in the middle of the road where you get hit by cars. Okay? So, how many pathways are possible? If you just start drawing them, you get very confused. Did I count them all? Did I miss some? What would be left? Okay? But if we look at one of these paths, if we look at this path, I could describe this path as I went east, then east, then east, then east, then south, then south, then south, then south. That would be one example. Another example could be this one. East, south, east, south, east, south, east, south, east. Okay? You see that this is becoming to look like a Mississippi question. Every time we rearrange the E's and the S's, we get a different path. So normally, if there was all 8 of those letters were different, you would have 8 factorial. But there's 4 E's, and there's 4 S's. And apparently, if you had a calculator, this comes out to 7. Now, pathway questions like this can be done like Mississippi questions. They can also be done with counting. And the way that you do it with counting is you say, I'm going to start here. And you go to each intersection. How many ways could I get to that intersection from home if I went directly there? Oh, my microphone is dying. Okay, I'll do a switch. There we go. How many ways can you get to here? One way. Same thing here. If you want, there's only one path to get to that one. In fact, this next intersection, there's still only one way. There's no other route than a straight route. Does it make sense that anything on the straight line has only one way? But this dot right here, there's 2 ways to get there. You could go over and down, or down and over, giving you 2 pathways there. And we're going to see if we can figure out a pattern. Okay, this dot has 3, this dot has 4, this dot has 5. Also, this dot has 3, this dot has 4, this dot has 5. I want you to see if you can figure out a pattern from the previous numbers. How many ways can you go to that one? Or you could count them. Right? You could say 1, 2, 3, 4. Oh my goodness, get lost. I'm confused. Counting them, it gets a little bit, because you're like, did I count that one already? What did I miss? Any guesses how many are going to be to get to that one? There's more than 3. More than 4. We could keep doing this until you get to the right number. I'm like, amazing. Perfect. It's amazing. There's 6. Now, why is there 6? Because the only way you can get, if you wanted to get to this dot, do you see that you could either get to that dot from this one or from this one? If there's 3 ways you can get to this one, and 3 ways you can get to this one, together there's 6 ways you can get to this one. What do you think this number is going to be? Right here. 10. And this one's 10. And this is 15. 10 plus 10, 20. 10 plus 5, 15. 15 and 20, 35. 35. And 70, same answer you get from counting. The nice thing about the counting method is this only works if it's a perfect grid. If all of a sudden there was like a big lagoon in here that you couldn't go through, then you would have to use the counting method along the points to figure it out. But we'll get to that in examples later on. Okay, circle number 12. Then we have time for our last question.